RxJS advent of code. So today we're going to be covering some of the stuff that I put up over the weekend, if you saw some of that. Basically, I wanted to cover a little bit deeper into what we were talking about with map and filter, and then go a little bit further talking about if you knew arrays, then you knew observables. And I started to mix in some things like iterables in there, and that's just to kind of get you up and running and ready for IX, which is the kind of the interactive counterpart to Rx. So when you think Rx, you think I'm pushing data, and with IX, I'm pooling data, and it's either synchronously or asynchronously, and we're good from there. So let's go ahead and get started today by looking at where we've been so far. So like I said in the beginning, if you haven't been keeping up so far, I just walked through creating an observable from default. On day 2, we walked over creating things using schedulers to make sure that we control the concurrency and everything else. By the 3rd day, we were creating our observables the easy way instead of having to hand create them ourselves with of, range, and generate. So by the 4th day, we were creating operators via the timer and polling operations. Those are really useful, especially if you're creating really long-running jobs and you want Rx to kind of continuously ping something, for example, or you're in a game loop, and the game loop you want to go 60 frames a second. Well, in order to do that, you can use an interval or any of those kinds of things to kind of keep track of your game loop, if it goes faster or slower, etc. So by the 5th day, we had the conversion operators. So those things where you can take an existing data structure and convert it directly to an observable. So this is really cool in the way that you can take an array, a set, a map, an observable, a promise, pretty much anything that you could possibly think of, and turn it back into an observable. So we covered that there, and one of the most common scenarios, obviously, is something like from array or from promise, most likely, what you're going to be dealing with. And by the 6th day, we covered everyone's favorite of converting to events, converting events to observables, and that's really useful, especially if you're doing things like mouse drags and converting DOM events and those sorts of things. You can also do some really cool things with event emitters, with pretty much anything that deals with events. We now have a really rich way of dealing with them, because now the whole add event listener and remove event listener is abstracted away from you per your platform, and that you can write the code that you really want to work on. So by the 7th day, we were talking about pipe. Pipe is a way that we can easily start to merge together different operators, whether it's map and filter and so on, and moving away from the dot notation that we've done before. And there are really good reasons for doing that that you can read on why we did that, even if it hurts discovery. There are really good reasons as to why we did that. So over the weekend, I worked on mapping and filtering. So here we had basically talked about this a little bit on Friday, but I wanted to kind of hit it home that if you know how to program with arrays, then you pretty much know how to, the programming model of dealing with observables. There's pretty much a one-for-one match when you're talking about map and filter and reduce from one to the other. One's being pull-based and one's being push-based. So mapping and filtering is pretty simple when you think about it, is that you can implement it on an array pretty easily by just iterating over there, creating a new array, so you're not modifying the existing one, and then you return results. Now, what's more interesting is if you start to do it with iterables, so that you can start to deal with infinite sequences. As in addition to arrays, you can use maps and sets and even generators with the same code, as long as they implement symbol.iterator property directly. So here we're able to pretty much call map easily, and this code is wrong. I'll fix that. But the idea is that we can say for of and iterate over this, and it will continuously go over this particular iterable and do the same thing. Implementing this for observables, we walked through a little bit of the code, but I just wanted to kind of simplify it for you as to how you would create this. First, you would have kind of our top level, which is the map, and the map it takes in a single thing of a selector. So we've got the selector, we've got the this are, and once again this code's a little bored. So once again, pull requests are welcome, but I'll fix this before too long. But the basic idea here is that we have our map operator as a function inside of there. So when you take the maps and the filters and so forth, and you do them for pipe, then that easily adds them up for composition because the source is applied later using kind of partial application, as it were, techniques. So we can subscribe to the underlying observable here, taking the value from our particular thing here, which is our selector, and if there's any errors, we project it to the error channel, otherwise project it to the next channel. And then we keep error and complete the same. And filtering data is kind of the same kind of interesting thing of basically creating a new result based upon whether the condition on your whether the condition in your predicate is true, and if it's true, then it'll project it to the new one. And implementing this once again for iterators, it is not really hard at all, because you just have if the predicate then yield the item, then we can filter and so on and so forth. So going through and doing this through observables, wow, I really did screw up some of my copy paste. So all right, anyways. So this should be way up there. So with filter, we have our way of calling subscribe and having should yield, and then should yield is anything that returns truthy. So our predicate could return 0, which is truthy. It could return true. It could return a non-empty string. Anything that's truthy would be able to yield here next. And so we've loosened the rules on Rx just and so that you can do that. So you can have those kinds of scenarios, since JavaScript is kind of loose with its typings and so on and so forth. And so we can implement here map and filter, import them both, and then project on to the next value. So going on to yesterday, I wanted to talk about reduce. So if we look at reduce, let's actually look for mdn array.reduce, and just wanted to give you an understanding of what reduce exactly is. So here, reduce executes a reducer function on each member of the array, resulting in a single output value. So this this one here has a reducer function callback that has the accumulator, meaning the thing that's been accumulated over time and that you keep returning from your reducer function, the current value that you're going to do something with, and JavaScript, being JavaScript, loves to shove in the current index as well as the source array, just because if you have a callback and you wanted to do some sort of analysis on the calling array, you can certainly do that. I think the last one's a little unnecessary in today's world, but we do support in Rx the first three here. So, like I said, it's a pretty easy concept to understand in terms of whether, how to kind of fold over your data little by little with an accumulator, and whether or not it contains this initial value. The initial value kind of tells you how you're going to, start your operation. So, for example, if you're doing multiplication on every item there, then you might want a seed of 1, for example. So the initial value will be 1. Then you can say 3 times 1, times 2 times, and keep on folding over the array as you see fit. But of course, that's optional. The problem with it being optional, though, is that if the sequence itself, if the array is empty, then it'll throw an error and bad things will happen to you. In Rx, we've kind of gotten away from that and just give you an empty observable, but all intents and purposes, you just don't have any data really to give them. So if you just don't have any data to give them, undefined is really not something you want to do. Is you want to specifically say, hey, you don't have any value here. So we can implement going over here by going over the result, and once again I'll fix up the code, but the idea is that we're going to iterate over the source, and whether it has a seed or not determines basically how we're going to project the next value. So if we do have a previous value or a seed, then we're just going to call the accumulator function with our accumulated item and our current item. Otherwise, if it's a brand new thing, then we're going to set our accumulator to our new item, and set the has value to true. And the accumulator basically just is now becomes the item, the first item in our list. So if we have an empty list, then it basically, instead of getting an initial value, it gets the first value, as it were. So we can now implement this pretty easily using Rx, kind of the same way, in that we have an accumulator function here, and that accumulator function once again takes all of that, and our seed is once again optional. And whether we have our seed or not determines what we do here. But what you'll notice is that we start projecting the data mostly here at complete, because in order for it to be reduced, it has to emit a single value, and that single value here is our ACK value, as it were, and then we call complete. So we've already implemented reduce, but we already have that in Rx. I just kind of wanted to show how how we can take a look at data in different ways in terms of implementation and seeing how the sausage is made. Now, what's more interesting is doing it via scan. So the ideas behind reduce are great in terms of the fact that you can reduce it to a single observable value. Note it's not a promise or anything, but it is an observable of a single value. But for it to give you any value whatsoever, you have to have an end to the sequence, which is not normally very useful. For example, if you've got such things as mouse clicks or mouse movements or what have you, where data changes infinitely, and what you want to really do here is build up a state machine, and scan is exactly that, which is to iterate over incremental values as they come along. So implementing this using iterables, you can iterate over for item of source. Then you can set the accumulator and then yield that item. So each and every time you're yielding an item as it goes through the accumulator, so you don't have to wait to the end to get results. So what we could do then is so for example, you clicked once, okay, now we have one click, 2 clicks, 3 clicks, 4 clicks, and keep on going through there, because our callback is nothing more than just adding one to our current seed, as it were. So here we can scan of 1, 2, 3, and the accumulator and the current value with a seed of 0, that we'll get 1, 3, and 6. So like I said, super useful if you want to keep a state machine going, because now you're going to start accumulating values over time. And implementing this using observables is pretty straightforward as well, in terms of in the next handler, you're going to see whether it has the seed or not, and if it does, then you're going to try the accumulator, catch any errors, set the seed back to the result, and observer next on it. Otherwise, you're going to set the seed to the first item and then send that out. So once again, it's pretty simple. That what you're doing is you're calling next on every single item that comes through, whether it's the first value or the accumulated values, through so on and so forth. So, for example, when you want to count mouse clicks, like I said right here, you can say ACK X and then ACK plus X with an initial state of 0. That initial state, once again, optional. You can put it in there if you want to. But really helpful to have these sort of state machines that you can build up asynchronously over time, so that you can do some calculations. And so libraries such as Redux kind of came out from that kind of design, where you're building your state machines over this concept of reducers. And these reducers are exactly what scan is to its very core. So for example, if you wanted to write something like a Redux style reducer, you would literally have your scan, implement scan, or not implement scan, but implement your reducer with some sort of initial state, and then subscribe to it. And that would allow you to then render the data as it comes through. And we'll do that in another session here shortly. Today I wanted to talk about a different set of APIs before we got there, just because I wanted to cover the times when we do have data and the times that we don't have data. So today, what we're going to look at is how we've been diving through the code. So I just wanted to introduce you to ReactiveX.io's RxJS documentation. So if you really want to look at the guts of everything, we have all of the operators and all of our exports are given here. So if you ever had a question of how much stuff we actually have, well, it's quite a bit in terms of everything that's exported here. I'm going to look in particular to a number of sequences, a number of things that we can do to make things a little bit more compositional in terms of dealing with that empty data problems that we had here before. So we're going to first start off with the start with operator. So if we look at that, what exactly does start with do? And so we load up that, and apparently nothing happens. Oh well. So let's actually dive into the code and make good things happen. All right, there we are. Sorry. So returns an observable that emits the items as you specify before it begins to emit items by the source observable. So anything that you give to it will be rendered before your main things come out. So for example, if you wanted to preface your mouse movements with coordinates x and y of 0 and 0, you can do that with the start with operator. Notice what it also takes is a scheduler-like object. And the reason why that is because we want you to have the ability to change kind of how that first sets of items are actually scheduled. And what it's really kind of using ahead of time is using the of, and so it can take of or from with that array. And what does that of and from require is a scheduler. So we're just kind of allowing you to allow that to flow through in such a way that that you can start to look at the data in any number of different ways. So hopefully that clarifies that. And what you can do is you can go of from our source and do from and start with first and second, and then subscribe to that with console log. And doing that is pretty darn simple in that we can say import of from RxJS. If we switch over to our code view, that would be actually more helpful. All right, so if we switch over to our code view, we can now say import start with from RxJS /operators. Okay, and so now we can say of 1, 2, 3 dot pipe, and we're going to say start with -1, 0, and 0. We can certainly do that, and then we can subscribe to that just by console logging. Okay. So then we can say npx ts node of 10 slash index.ts ta-da 0, -1, 0, 1, 2, 3. Pretty simple. And the reason why this is good is because, like, for example, if you have some sort of initial state that you want to introduce to your reducer or something like that, start with is a good way to do that. You know, we have seeds, but we can also use start with there as well if we so desired. Just as we can add to the beginning of an observable, we can also add to the end. So for the longest time, I had kind of avoided allowing this because I'm like, well, no. You know, observables are really long-term, infinite objects, and ending with something implies that there's an end to it, and that's fine. I eventually relented, and we ended up with a pretty good API for that as well. So we can say end with so for example, if we're going to take some sort of sequences and we want to end something to tell something else that we need to send some sort of data or packet or whatever, something to indicate something else should happen, you can send that with end with and go through and do it that way. So going back into our, sorry, I forgot that, end with. So end with, once again, kind of like start with, comes with the array and allows us to go through and pretty much add in our scheduler-like things that we've done before, where we're scheduling items afterwards. It's no more than just calling concat from something else. Its implementation super simple, but like I said, you could have implemented a lot of RxJS yourself if you had the time, the patience, and the wherewithal to do that. So switching back here to the code, then we can go through here, and we can also get end with, and we can say end with and 4 and 5 and 6. So once again, you can go from -1 to 6 just by adding start with and end with, so that you really have control over both sides of the observable there. And for the interactive or pool-based model, we have the same APIs allowing you to add to the beginning of iterables and async iterables in very much the same way here. So that's really cool in terms of it allows us to easily add things to our data, whether it's in the beginning or at the end, so that we can change our state models and our state machines as we need to. And so if we look at one more that I thought was fairly interesting when it comes to these sorts of things, is default if empty. So the problem is, like I said, is that if we have an empty stream for whatever reason, that it just never yields us a value whatsoever, then we're going to say, well, then give us some sort of default, whatever it happens to be, and move on. So this also allows you to handle those cases where, okay, I didn't get any data at all. I want to give cache data, for example. So default if empty, we can give it cache data. If for example, we didn't get any data from the cache, we can pull something else out in that particular case. We'll talk more about error handling at a different point if that's the way you wanted to go from there. But default if empty is a way to allow you to add data if none exists. So going back here, we can go back into our code and pick up empty here, and then we're going to also pick up our default if empty operator here. So now we can say, okay, empty, and there are genuine reasons why we will do this, but now we can pipe our empty with default if empty and give it 42. So if it's an empty sequence for whatever reason, we can do that. And we can also then start it with some sort of data, -1 and 0, and we can also end with 4, 5, and 6. And now, so we're giving it a single value for default if empty, and then we can call subscribe on that, and that should give us the value that we expect, which is the, all right, it apparently didn't because I'm doing something wrong. All right, maybe because I didn't do that right. All right, so empty, default, if empty, I'll figure it out. Talk about me being rusty with my own code sometimes. That's kind of cool. Anyways, so we're about at the 30-minute marker here. So if anyone has any questions, like I said, feel free to send me those either here or on Twitter at Matt Podwysocki, at MattPodwysocki, and I'll be sure to answer them the best way I know how. So I'll get this lesson written up and published out there, and I'll fix a lot of the bugs that I did find along the way here. But once again, pull requests are welcome for that as well, if so desired. So thank you, everyone, and I hope to see you next time. And if you've liked what you've seen so far, please do subscribe to my channel, Bluer Than Blue Falcon, and I will see you next time. Thank you. Bye-bye.